Hi, I'm George with AmateurLogic.TV, and I'm talking today with Clyde Haehnle, a broadcast engineer from the Cincinnati, Ohio area. Clyde, we really appreciate you taking out time to talk with us today.
Glad to do it. It's my honor.
And you've worked in broadcasting most of your life?
All of my life.
All of your life.
Started in 1941. I was a co-op student from the University of Cincinnati. My first job was to work down at WLW, midnight to 8 a.m., running the old 500,000 watts during the experimental period.
Tell me about that. That had to have been some experience.
It was a real thrill. At midnight, we'd sign off of 50 kilowatts. We'd fire up to 500 kilowatt. The fire-up procedure took about a half hour before midnight. We turn on the air and the water on all the. There were 3 power amplifiers in series. They were about 200 kilowatts each. There were 2 modulator units and 1 power supply. And then we used the 50 kilowatt as a driver for the 3 power amplifiers.
And a 50 kilowatt, I mean, that's the biggest you can have on the air today.
Yeah, well, that was our driver. And we loaded that thing up at one night to 700,000 watts.
Wow.
And it was a real thrill. It's a real thrill if you're an amateur to dip your plate currents to 100 amperes.
Boy, I bet.
You rock it through resonance, and that really felt good.
What kind of voltage plate voltage did that
15
run?
kilovolts.
15K.
We had 24 tubes. They were 898As. They were 100 kilowatts each. 7.5 kilowatts just to light the filament on each tube. And we had 30 gallons per minute of water to cool the anodes.
Wow.
It's a 6-phase on the filaments. 7.5 kilowatts.
So, what was your first job there?
Well, at that time, to get the distilled water up to the plate anode voltage, we had to use Pyrex pipe. Mm-hmm. There were none of these ceramic isolating coils available at that time. And I was only about 100 pounds. I was the only guy who would fit down in the vault to stop the leaks in the Pyrex pipe. So that was my main job. Then after we signed off, I would go through, we'd run the 500 kilowatts from midnight to 2 a.m., non-commercial. My job then was to go through and check for leaks in the water, feel every capacitor for heating. Any heated capacitor I'd have to change. Check all the connections. That took about 2 hours, and then I'd have it by teed.
Wow, so you'd have to climb up inside the transmitter to do all this.
Well, there were 3 power amplifier cubicles, 2 modulator cubicles, and the rectifier cubicle. And you'd have to move from one cubicle to the next and isolate each one. It was a fascinating job. I learned a lot about transmitters doing that.
Oh, I bet. Did you use the, I guess we called them the Jesus stick to...
Hot sticks?
Hot sticks, yeah, to short everything out before
Well, no, before you could get into a vault, you had to pull up a bar, and that grounded all the high voltage in that cubicle.
Okay. So they had some safety built in.
Oh, there was a lot of built-in safety on that, yes.
That's the only, I guess, 500 kilowatt that RCA ever built in the U.S.
Well, RCA, GE, and Westinghouse, all 3 built it. Westinghouse built the cooling system and the power supply. GE built the transformers. RCA built the modulator. And by the way, our modulation transformers, we had 2 modulation transformers, 12 feet high, 8 feet in diameter.
Wow.
They were huge.
Did they have PCBs in them, you think? PCB oil?
At that time, we didn't know what that was.
Yeah, I know. Did you work with any of the engineers who were there when it was built?
No, it was built in 1933 and 34. I didn't start until 41. It ran from 1934 to 1939 as a full-time operation, daytime, commercial. 1939, Senator Wheeler of Montana railroaded a resolution through the Senate limiting the power of broadcast stations to 50 kilowatts. And so we had to shut down from commercial operation, but we operated from midnight to 2 a.m., non-commercial. That's when I was involved.
Mm-hmm. So you said you had to go in after the transmitter was shut down and feel for warm components. Did you ever find any?
Oh, yeah. Every night you'd find something wrong.
Really?
Every night. And you'd have an explosion. In fact, the tower had 8 guy wires. It's supporting the tower. You can see it down the road. And if it got struck by lightning, the lightning would jump across the ball gaps on the guy wires. Well, the transmitter power was enough to maintain the ionization of the arc, so you had to shut the transmitter off to stop the arcs on the guy wires. So we had to build an electric eye pointing to one of the gaps in the base of the tower. When that flashed, it tripped the transmitter off to deionize the arcs.
So it would sustain its own arc once it got started?
Once it got started, yes. It was ionized.
So what did you use for transmission line? How did you get 500 kilowatts to the base?
Oh, it was easy. It was a 10-inch aluminum pipe with a 2-inch aluminum center conductor supported with Michael-X. Air dielectric, no gas, no pressure. So it was a 100-ohm line. It was 10 inches in diameter.
So what was the output impedance of the transmitter? Was it 100 ohms or was it 50 and you matched it down to the 100?
Well, we went to a 100-ohm line. We ran, the base impedance of the tower was 396 ohms. We ran about 11 amps at 50 kilowatts, 30 amps at 500 kilowatts.
That's a lot of current. A lot of base current.
Well, a lot of plate current when you got total plate current of 100 amperes.
Yeah.
We used to run 15 amps of grid current.
Wow. and most transmitters, recent tube transmitters wouldn't even run 15 amps on the plate.
Most of our competition was 5 kilowatt and 250 watt stations. Well, we had 24 tubes that took 7.5 kilowatts each to run just to light the filaments.
So did you ever have any problems with rodents or anything?
We had a bank of filter condensers in the power supply. The rodents would get across those and explode.
Yeah, just find little pieces, I guess.
Find pieces all over the basement. And we had delta Y breakers to start the transmitter up from a delta to a Y connection.
Huh. So you'd actually have to shift it during startup.
Oh yeah, you put on low voltage and you shift to the delta Y breaker.
I guess
the whole building shook when you did that.
At 500 kilowatts, I guess you really couldn't have a backup generator, could you?
Oh no, we had a power source from Cincinnati Gas Electric, from Dayton Power and Light. So we had 2 power sources coming in.
Yeah. Were there?
We had our own substation.
Wow. Were you fortunate enough that both of them never went down at the same time? That during your period, you always had power from one or the other?
Oh yeah, so always had some power. We never had lots of power.
What kind of matching network was there at the base of the tower?
It was an L network.
An L.
L network. We went from the 100-ohm line to the 371-ohm base impedance of the tower.
That's a pretty high base impedance.
Well, it's a half-wave tower.
Yeah, well, yeah.
It's a half-wave tower.
Now, I had heard stories that originally that tower was a little taller and that was a problem.
Yes, that was. Tower was 5/8 of a wavelength tall at the beginning. When you have a 5/8 wavelength tower, you get good field of a mile in the horizontal plane, but you get a secondary lobe. That secondary lobe landed in Indianapolis and Columbus, caused a distortion zone during sunset period. So we had to take the flagpole off, dropped it from 831 feet to 708 feet, and went from a 5/8 tower to a half-wave tower.
Wow. And
that stopped the distortion in Indianapolis and Columbus.
And I guess those areas just were far enough out that was cities you wanted to hit.
Oh, that's right. They were 100 miles out. And that secondary lobe hit the ionosphere and came right down at 100 miles out.
And I guess counseled with the main lobe.
With the ground wave.
Yeah.
Caused the selective fading, as they called it.
What about nighttime operation? Was it, did you get, I guess you would send out QSL cards, but did you get reports from quite a distance?
Australia?
Australia. That's about as far as you can go, I think.
We had consistent listeners in Southern California. But, of course, at 700 kilocycles, your coverage during the summertime is limited because of atmospheric noise. We did an extensive study on atmospheric noise relationship to class of reception. Instead of going to actual millivolts per meter, we went to ISO service contours, constant signal to noise ratio. So we knew where the noise was. We measured atmospheric noise. We measured man-made noise in the cities.
I bet the man-made noise now, today, would be so much higher than it was back then.
Oh yeah.
That's really kind of killed AM with everything, all the garbage we put out in the air today.
That's right. We went out to all different sized cities and measured man-made noise in the cities with a vehicle, and we come back and correlate that to the population of the city. And if we knew the population, we knew what the man-made noise was. So we knew what strength of signal we had to get in there to provide satisfactory coverage. We had 3 classes of coverage: A, B, and C. A served 90% of the time, 60% of the time, and 30% of the time for the 3 classes of service.
And WLW is non-directional and always has been, and that's still the original tower.
Well, we were directional in the vertical plane pattern only to protect our signal up to Toronto when we were interfering with KFRB at 690.
In the vertical plane.
Yeah, we had a null in the vertical plane pattern only. Fritz Leidorf designed that. We had 2 suppressor towers, several wavelengths away from the main area, and they just caused a null in the vertical plane pattern toward Toronto.
So the ground wave was
non-directional.
Yeah. Well, that's quite interesting. I guess that's probably the first time that had ever been done.
See, I think it's the only time that was ever done.
So that's an old tower. I don't remember what year WLW came on the air.
1934. The tower was built in 33.
33.
That's 2 Blawnox H40s back to back.
Oh, yeah. Bottom one's upside down.
Bottom one's upside down.
And there's this one, I guess. There's still the one in Nashville.
Yeah, WSM.
Are there any more left?
There's one in New York, W. It's got a smaller tower on the bottom and a taller one on the top. It's one in New York, and I don't know where the other one is.
Yeah. The stations I used to work for, we had some old Blawnox towers used as STLs. They were only 125 foot tall, but they looked in that same style with 4 legs.
Yeah, the old design.
Yeah, but those things have really stood the test.
They sure did. They were used for, in the 40s, the late 40s and 50s, they were used for TV towers.
This particular one here?
No.
Oh,
the Blawnox. Yeah, the old Channel 5 tower was a Blawnox tower, just half of this one, 500 feet.
Wow. And how big are those guy wires? I have.
Those guys were about 2 inches in diameter. The breaker insulators, or 4 breaker insulators in each guy wire, they weighed 600 pounds each.
Boy.
They were big.
Yeah.
They're about this big.
And there's resistors across those.
There was drain resistors across them. What else we did, we put a wooden jig in each guy wire and put a hard steel slug 2 inches up from there in a slot. After we get hit by lightning, we take that slug out, measure how much it was magnetized from the lightning current going down the guy wire, multiply that by eight guy wires, then check the base one, figure out what the amplitude of the lightning it was. We calibrate that as high as 40,000 amperes.
Wow.
Lightning current. Then we also had a steel ball on the top of the tower. It was all full of holes from lightning hits. We took it up to GE and calibrated that, came out with 40,000 amperes.
At that height, you're going to catch just about any storm that comes through.
We caught a lot of them. We had 250 kilowatts of audio.
250
kilowatts of audio to modulate the transmitter.
Yeah. Yeah, I guess, yeah, you'd have to. But was that enough to get 100%?
Just barely.
Just barely.
Barely. It was tough.
Did you have compressors and limiters back during that day?
Well, what we did, maybe I shouldn't say this, but when you'd shift from 50 kilowatts to 500 kilowatts, the automatic volume controller receiver compensated for most of that. People couldn't tell the difference in the primary coverage zone. So what we do is before we'd shift, we'd cut the modulation down slowly. So by the time we were shifting, we were only modulating about 50%. And then we came on with the 500 and 100% modulation. and you'd jump in your seat.
You'd know that it had been turned on.
We knew that it was turned on. Yes, we had homemade automatic amplifiers. We'd actually, I forget how they work now. My mind's not clear as it was in those days.
So how was, of course, you know, the studio was located in Cincinnati.
Studio was in Cincinnati, yes.
How did you get the audio from the studio out to the transmitter?
Telephone lines, equalized telephone lines. Then when we went to high fidelity transmitter, the cathode system, we had to put in a microwave to get the signal out there in high fidelity form. That was an interesting transmitter.
Really?
We were flat from, we had the audio under control from 2 cycles to 600 kilocycles, audio through the modulator under control.
Wow.
And shaped, we had 50 dB of feedback, 48 dB of feedback. And we were flat from 20 cycles to 20 kilocycles in that transmitter with about 0.5% intermodulation distortion.
That is tremendous.
Well, that was a lot of work.
So what did you cut off the top end audio at? Did you let 20 kilohertz go through?
Yes, sure.
I'll bet that sounded great on some of those old radios.
It did. Those old crystal sets, we had real broadband crystal detectors feeding into a good hi-fi amplifier.
And so you had to have a man there on site, I guess with it being a 50 kilowatt, 24 hours a day, there was a man there responsible for taking meter readings every 30 minutes?
Every 30 minutes, we had 2 men on duty because of the danger of the place. We had 2 men always on duty.
You were just telling me about the hi-fi transmitter there. Who built that?
Rockwell, Jim Rockwell, my boss.
Okay, so that was a custom built?
Custom built cathode, non-ferrous. No audio went through a transformer.
Really?
Yeah, it's a totally non-ferrous audio all the way through to the output.
Gee.
That's how we could get the low distortion.
Yeah. And now there's, I don't know, I guess maybe 3 or 4 transmitters in that building, just different generations.
That's right.
So the original transmitter was that 50 kilowatt Western Electric?
Western Electric, yeah. And, 1005 was the serial number.
Wow. And then you went to the one Rockwell built?
Well, we modified that old Western Electric several times, changed the tubes in it, changed the tank circuit, changed the modulator. So it was a composite by the time it...
But yeah, retired. Yeah. And what did you go to next?
I was down there until we built this place in 1942. I came up here from 42 to until we got this on the air. Then I got involved in television. I built WINS in New York City. And then I built several television, Cincinnati, Dayton, Columbus, Indianapolis television, San Antonio, and then the 7 stations in Saudi Arabia in 1969.
Did you ever work with Rockwell?
Oh yeah, I replaced Rockwell.
Oh, you did?
Yes, he was my boss. He and I were very close. I worked hand in hand with him all the time.
How was it to work with him?
Charming man. We said he used to think like a vacuum tube. He was a bulldog. He wouldn't give up. He'd try and do something that wouldn't work. He would never give up. He said, it's got to be able to finish this. His theory was the difficult we do immediately, the impossible takes a little while longer.
And you worked with Crosley as well?
Well, that was Crosley. Powell Crosley hired me. And Powell Crosley was around till 1945. And then it was bought by Avco Corporation. So I didn't get to know Powell very well.
Yeah, but you did work with Rockwell for a number of years.
Well, I worked with Rockwell till 1977 till he died. I replaced him. I took his job. We tried to sell our patent to Gates, and it was too complicated for the average operator.
Yeah.
So we didn't go very far with it. It was a difficult transmitter to operate. It was good.
Oh yeah, those specs are unheard of. AM, I guess even today you won't.
Not in AM. In fact, those are even good for FM.
Yeah.
We had 65 dB noise level.
You left WLW for. Why did you leave there?
I didn't leave.
Oh, you didn't?
I was there for 40 years.
Okay.
Never left.
Never left.
Couldn't get rid of me.
Well, what about VOA? How did that play
Well,
out?
that was Crawley's project.
Yeah.
That was done by the Crawley engineers. We designed this place.
And so you worked at both facilities.
I worked down there and worked up here, yes. I did the antenna work here, transmission lines and antennas. We developed the reentrant Rondwick antenna system. You familiar with that?
Yeah, yeah. I'm just sorry that it's not out here. We can look at it, but that was quite a system. Tell me a little bit about how that...
Well, what we did, we had it down the road. We had two shortwave antennas down at Mason, and a 75 kilowatt transmitter and a 50 kilowatt shortwave transmitter. But those were small antennas. We used lump parameters to phase the feed line, return line back into the input. And it was very, very sensitive, very delicate, very difficult to tune. So we built 4 more antennas across the road, larger antennas. We started using lump parameters on those. And I was in college doing well at that time, studying under Professor Osterbrock. He taught a course in transmission line theory. He said, now there's the beer can theorem. I said, what in the world's a beer can theorem? He said, well, you can hang anything on a transmission line, even beer cans, go a quarter wave down, put the same disturbance on the line, and you won't upset the match of the line, but you'll change the phase rotation between the two disturbances. I thought, gee, that'll work well with our rhombics. So the rhombics we built here were phased with matching stubs instead of lump parameters. We had K factors. We had increased the efficiency, radiation efficiency of a rhombic from 60% to 98%.
Well, that's a significant
Well,
increase.
when you throw away 50% of your power in a termination,
Yeah.
just save that and feed it back in the input again.
So that you were feeding from the output back to the input of the antenna circuit,
Yeah.
and it just by phasing it correctly, you could just
Phasing and impedance matching it correctly,
Yeah.
you could return that power to the common point and put it around the antenna again.
So what kind of gain would you get out of an antenna like that?
20 dB
That's significant.
with 200 kilowatts.
Yeah,
It lays a pretty heavy beam.
yeah. And of course, VOA would change frequencies throughout the day.
Well, we had these set up with stubs that we can set each antenna up for 4 frequencies. And we had 4 certain frequencies assigned to us. We had antennas were in different groups. There was an A group, B group, and a C group, different sizes. We had a 6 megahertz to 9, 9 to 11, 11 to 15. No, 6. Let me think. 6 to 11, 11 to 15. We had 2 transmission lines running out to 3 antennas. We'd switch the transmission line between the low band and the high band antennas. But then we had to come back here and match that line, real broadband step transformers, because we kept our VSWR under 1.1 to 1 all the way back to the transmitter output.
So the switching matrix network out here, was that strictly switching the antennas, or did it also switch the tuning networks?
Oh no, just the antennas.
Just the antennas.
It took the output of 6 transmitters and fed them into any one of 24 antennas. It was a crossbar switch. You're familiar with the old crossbar switch.
Yeah.
300 ohms. And we have to go from 300 ohm output of the switch to the 525 ohm transmission line through stepped impedance transformers.
And I've seen the transmission line down here. I've never seen anything quite like that above that Continental that's down there now.
Oh, that pipe?
Yeah.
Well, we had the 300 ohm lines were about 1/4 inch diameter copper weld, 3 inches apart vertically and 10 inches separated. So there were 4 wires about like this. That was a 300 ohm line to feed out the selector switch. Selector switch was 3/4 inch copper pipe on 10 inch diameter, 10 inch separation. That was a very, very low VSWR all the way through that.
When the war came on, I guess that's really when the government got interested in bringing the Voice of America online. How long did it take to plan all of this out and then to construct it and get it on the air?
President Roosevelt called a meeting in just several months after Pearl Harbor. because we had only 13 shortwave transmitters. The Axis countries had over 100.
Mm-hmm.
And he said we're not physically equipped to engage in psychological warfare. We need to build some heavy-duty transmitters. So he called a meeting in Washington with RCA, Westinghouse, General Electric, NBC, CBS, Crosley, and other manufacturers. And our chairman of the board, Jimmy Schaus, went to that meeting at the White House. During a break at the meeting, he called Rockwell and said, "Rockwell, can you build 200 kilowatt transmitters for shortwave?" Rockwell said, "Hell, I don't know, but I'll give it a hell of a try."
Yeah.
That's all Schaus needed. He went back and committed us to build 6 200,000 watt transmitters and 24 antennas. And we got a contract on 1 sheet of paper to build this place.
Wow.
1 sheet of paper. And from the time we got the contract, from the time we broke ground till the time we got the first transmitter on the air was 1 year.
That is moving
Now, there were no
on.
tubes available for the transmitters, so we had to send Jim Hollis, our transmitter guy, to Nutley, New Jersey, the federal tube plant in Nutley, New Jersey, to design the tubes that would fit in the transmitter.
And you did all this in a year.
1 year.
Boy, I guess that you had a really large crew,
8 engineers.
8 engineers, and then
Well, three of us didn't work on transmitters. So only 7 of them worked on the transmitters. The 3 of us worked on the antenna systems.
who built the towers? What brand of towers did you have here?
Well, they were poles when we built it. They were just wooden
Okay.
poles, butt spliced, 180 foot tall after they were butt spliced. But then in 1951, we put the curtain up. The curtain was, those weren't Blahnox, those were, I don't remember who the manufacturer was, but that went up in 1951 during the Army McCarthy hearings.
Okay, but so back during the war period, then that was wood poles.
Wood poles.
Wow, 180-foot wood poles.
No, they were 90-foot poles butt spliced.
Okay.
We built a sleeve about the size of this table, about this big in diameter, and put the butt of each pole into it, and they were butt spliced together to reach it.
Mm-hmm.
They were guided in the center, the top.
This crossbar switch out here, that's mostly all the original wood from.
That's the original wood. We built a model of that, scale model of that, before we built the switch.
That's quite a complicated looking rig out there. Did you ever have any arcs or anything?
Oh yeah. Every once in a while you get a switch that didn't close tight and it burned. In fact, we actually set up demonstrations at night, caused arcs. We could get 10 feet of flame coming off the transmission lines.
That's pretty good. And so WLW is just right down the road here.
Right.
I mean, you can step out here and see the tower just really good. Was there ever any interference from one to the other? Did you ever have RFI from say VOA getting into gear at WLW?
Well, the problem that we had, we were concerned that when we put the curtain up, we would affect the non-directional pattern of WLW.
Mm-hmm.
So we worked with the Air Force, got a helicopter, and did a lot of research work and found it was a minimal disturbance. We did a lot of work on that. But yeah, well, when we built our shortwave antennas down the road with WLW at 50 kilowatts, we had a lot of trouble with, we couldn't teach the electricians to work barehanded instead of gloves. They always wanted to use gloves.
Yeah.
Go right through the glove.
Yeah. Yeah. Well, I had a engineer one time helping me with the directional antenna system. It was Ted Hightaker, worked for Earl Cullum.
Well, I knew Earl Cullum,
Yeah.
Texas.
They designed the AM directional system we had at the station I worked at, WJDX. And of course he did the typical Earl Cullum phaser. It was in a brick building on the wall down there at the center tower rather than being in cabinets. But the thing had been out and nobody was able to bring it back in, so we hired Ted Hightaker to come in and help us put that thing back in. And he wanted me to climb the center tower, which was on during the day at 5 kilowatts. It was on 620, so it got out pretty good. But he wanted me to go check the sample loop on it. And I said, well, I can't touch that tower. It's 5 kilowatts. He said, oh, there's nothing to it. Get your wood ladder and lean up against it. And I said, okay. And he said, now take this pair of pliers,
I took a crescent wrench all the time.
crescent wrench. And he said, just grab it with that and then just break the paint and just go on up it. And it worked. If I'd had on gloves, though, that wouldn't have been so good, would it?
No, we sure wouldn't. But we climbed the 500 kilowatt tower.
Really?
In the day while it was on the air, with a big wooden ladder.
Gee. That's, of course, the FCC wouldn't let you go anywhere near doing something like that today. They've tightened up the, RF rules and all. But so you worked at WLW. You came over here. You built the VOA across the field. Did you work at any of the other VOA sites that were built?
No, just this one.
Okay, just this one. And were those others built around the same time?
About the same time, yes.
About the same
GE
time.
built one, and NBC built one. We're in Dixon, Delano, California. Brentwood. There was one in Jersey. One of the interesting things about the reentry aerobics, back during the Cold War, State Department called and asked me if I would entertain the chief engineer from Broadcasting Corporation of China in Taipei, Taiwan, who wanted to reach the free Chinese behind the bamboo curtain, was going to build a facility like this in Taiwan to broadcast their voice into behind the bamboo curtain. So I said, fine. I said, but it's classified. What can I tell him? I said, open the floodgates. Anything he wants to know, help him. So the first thing I asked him was, what do you want to learn about? He said, I'd like to learn about the reentrant rhombic antennas you designed during the war. I said, we never published any papers on them. They were classified. How'd you learn about them? He said, I learned about them through the underground. He knew my name and all the guys that worked with me on them.
Wow.
He said he was in Manchuria.
Gee. So there's guard towers up here at WLW to protect it during the war, and I guess same thing here at VOA?
Well, we had guards up in the tower here. That's what the tower was for. High-powered rifles, searchlights.
Do you know if they ever had to shoo anybody off?
Well, we'd all call them at night, but then every once in a while during the night you'd hear some gunfire, but they were shooting rabbits.
Oh.
But we had one tower was bombed here during the Cold War by some mentally deranged person. We had 2 bullet holes in the side of the building here, but that's all I know about. Nothing serious.
Is there any other stories that come to mind, funny or just scary or different about WLW or VOA? Just something you might remember through the years?
Well, we had one of the technicians who worked here was bald as a cue ball. And the transmission lines going out the side of the building here were 300 ohms at 200 kilowatts each. He was on top of a truck. He went under one of the transmission lines, arced to his head, just burned all the skin off the top of his head. We rushed him down to Doc Batchy down here, bandaged him up. After we took the bandage off, he started growing hair.
Oh, I wonder if anybody ever tried to patent that method of hair growth.
Well, we had enough trouble with that with the Crosley's Exervac. You know about Crosley Exervac? Well, Crosley was concerned about losing his hair. So he designed this machine that a big cup on the top of your head that would suck vacuum, then pressure to massage your scalp. It's called the Crosley Exervac. He put those in barbershops. You get a Crosley Exervac treatment. Well, the Federal Trade Commission got on him for being questionable practice. And so he had to separately incorporate the broadcast facility. So that's how we became a separate corporation, because that damn Crosley Exervac.
Do you think the Exervac actually worked?
Well, they sent one to us, and we said the only way it would work if you get the suction high enough would suck the hair off your chest and pull it out the top of your head.
I know Crosley built radios, and he built WLW, was instrumental in VOA. Did he have any other projects going on besides the
Oh, yeah,
the
an airport.
Exervac?
He built airplanes, built cameras. We owned WINS in New York City, broadcast the Yankees, and he had a big home in Florida. And he built the Crosley automobile.
Wow.
He was he was more interested in automobiles than he was in broadcast.
WLW VOA. What did you do next?
Well, I built a bunch of television stations. Let me think. The VOA, WINS, I spent 3 years in New York City building WINS. I used a helicopter in 1949 to measure the pattern because we had re-radiation from all the other towers out in the swamps. That was the first time we used helicopter for field intensity measurements.
And I guess that's the only way you could get to those points is...
We didn't get to points. We flew radials. We didn't stop and have measuring points. Came back here, installed a curtain in 1951. Got that going. And built some television stations, Cincinnati, Dayton, Columbus, and Indianapolis.
Did you like television as well as you liked radio?
Well, I liked radio because all the time we had 3 full orchestras in radio. We had live talent. We had 100 employees at the radio station.
Wow. Well, it was a big station, and radio was big.
We did $1 million a month in business, I remember.
Gee. And in dollars in those years.
I spent a lot of time in Washington representing the broadcast industry on the Clear Channel Broadcasting Service. Then the Association of Maximum Service Telecasters. I was chairman of their engineering committee for about 15 years.
Okay. Was that difficult to do, to keep the channels clear? Was the FCC trying to break it up?
They were trying to break us up and duplicate all the channels, and I was trying to maintain them, and we didn't make it.
When you got into television, was it brand new at that point?
Oh yeah, it's 1949.
49.
49.
So everything was black and white.
Yeah, we started in 1938, built from the old 440 line standards, had a television station, the Crew Tower, with a biconical dipole. In 1938, when the war came along, we turned that off. After the war, we turned it back on. Then after 1949, 48, 49, we got the new standards, converted that to a 525 line system. We built our own cameras.
You did? Videocons?
The old iconoscope. Remember the iconoscope?
Just barely. I never saw one.
I got one downstairs.
Oh, really? Cool.
Iconoscope camera. It's a trapezoidal picture because they scan it from an angle. And we had to put so much light on the subject, you could smell the wool in their clothes scorching. They couldn't stand under the lights more than 3 or 4 minutes.
Wow. But it got television started.
We got television started. And then we bought the RCA cameras with the old first image orthicons.
Television took quite a bit more bandwidth. Was that a challenge getting the antenna systems and?
Well, that was interesting because RCA did a real good job on coming up with the antenna system. I did a lot of work on establishing the accurate ratio of visual power to sound power.
Oh, you did? Yeah, because we used to think you had to have as much oral as you did visual.
That's right. And I got it down to 10% because when you ran 50% oral power with a color picture, that sound carrier interfered with the subcarrier, and you got some grainy pictures.
Yeah.
So I got that picture down. So I got a lot of papers I wrote on that.
Tell us how that works. That's real interesting that you would think you'd have to have the same amount of power to go the same distance, but you don't.
No, it's kilowatts per kilocycle of bandwidth. So if you compress it, you don't need that much power. If you spread 50 kilowatts over 6 megahertz, that's not much per megahertz. Mm-hmm. So you can have a little bit of... In fact, I ran a picture to sound power ratio test one year, 256 to 1, 256 times more visual power than audio power. And nobody could tell the difference.
Wow. So that was quite a bit of power savings and tubes and everything else.
Right. In fact, I shut the sound transmitter down one day and multiplexed the sound carrier through the visual transmitter. And nobody could tell the difference.
Wow.
It's hard to keep the tubes working right because every time you drive a sync pulse through, you'd cut the sound carrier off a little bit.
Yeah.
You get a little bit of buzz.
Yeah. That's pretty amazing. That's because that really wasn't that long ago that that we were running the same amount of power
That's
on
right.
both.
No, we ran 2 to 1. The initial starts was twice a. Yeah, if you had 100 kilowatts of video, you had 50 kilowatts of sound.
Okay.
And I got it down to 10% or less.
And today, it's all digital, so there's no separate aural or visual transmitter. It's
Right.
all just one, and a fraction of the power of what we ran in
And a
analog.
much better picture.
Much better picture. I'm not sure. I think the jury's still out on if you got the same coverage area you had before. At least where I live, I know some people that lost coverage after the conversion. But everybody had an antenna outdoors back in those days,
right.
I guess. Have you always worked in broadcasting, Clyde, or did you
No,
work in some other areas?
In 1975, our parent company was in Cartervision. Remember Cartervision? And Seaboard Finance.
I'm not sure I remember that.
Well, Cartervision was the first cartridge television device ever made.
Okay.
They invested a ton of money in that. They invested a lot of money in Seaboard Finance, which is a Canadian financing company. Both of those went belly up. They had to liquidate some of their companies, and they decided to sell broadcasting. So I was involved in the liquidation of our company. So I spent 2 years selling the assets of Avco Broadcasting Corporation. Raised about $300 million. I thought, this is fun. I think I'll do this for business. So I got in the investment banking business. I spent the next 15 years brokering radio and television stations.
So I guess that was a little more profitable than being an engineer.
It sure was. It sure was.
Yeah, that's but that's part of the industry. I mean, you've got to have all of these pieces to make it work.
Yeah, I was the only broker that could read a schematic diagram.
And I bet you could go out and look at a facility and tell if it was really worth what.
I appraised
were
television
wanting.
stations without even looking at them.
You could.
Sure, because the amount of equipment in a station is insignificant to the value of the property.
Wow. It's in the advertising revenue?
The license and the revenue, yes.
Yeah.
So I could appraise a station by just looking at the books without even looking at the station.
Did you like that line of work?
I enjoyed it thoroughly. I made a lot of money.
Yeah. So did you retire from that, or?
Retired from that. Well, I retired from that. Then I went into the appraisal business at home, and I closed that company. Did it at home and did special consulting work, a lot of depositions. And then when I was 83 years old, I hung it all up.
Hung it all up. And you were instrumental in getting J-Corps.
I was involved with
Involved with it.
but I wasn't instrumental.
Okay.
I was not one of the prime movers of that.
Okay. So, what do you think about broadcasting's future? With the internet here today, do you think broadcasting's got what it's going to take to hang in there, or do you think we need to pay attention?
Well, I think we're going to have trouble. I see more and more advertising showing up on cable network stations, and that's all advertising that would have been on the over-the-air station. So I think it's going to be a rough road.
I think so.
It's going to be a real rough road.
Yeah, because the advertiser can usually buy this time on cable a little bit cheaper than they could buy.
A lot cheaper.
Yeah.
I think AM radio has a place, but for broadband coverage like clear channel stations.
What do you think about digital radio? That
I'm really not up on that.
Yeah.
The parade passed me when that came along.
Yeah. You didn't have to worry about that.
I didn't
one.
worry about that.
Yeah.
I'm glad I'm not an engineer today because I couldn't design one of these cameras.
No, I couldn't either. I can barely figure out how to turn it on and run it, but it'll pretty much run itself if you can ever get it on.
But no, the parade went past me a long time ago.
Yeah.
So I'm glad I'm not an engineer these days. Oh, it was a great career.
It was, and it sounds like you were right on the cutting edge for all these decades.
It was a lot of fun, particularly the 500 kilowatt and developing this facility. That was a lot of real basic raw engineering.
I've heard stories, I don't know if they're true, about people hearing the radio station in their bed springs.
Oh, yes.
And stuff
A
like
lot of that crosstalk.
Yeah.
And fence posts,
fence posts. Yeah.
downspouts. We had a crew going around just putting in self-topping screws in downspouts to make a connection so there wouldn't be any cross modulation there.
So let me ask from an engineering standpoint, when something like that occurs, is that energy wasted that could have been broadcast out over the air? Is that actually being wasted there at that downspout?
Well, that's a small amount.
Yeah.
Like the ground system. We've only got 58 radios in the ground system at WLW.
Really?
This half-wave tower doesn't need a ground system.
Yeah, true.
Okay?
Yeah.
People think you need 120 radios.
Yeah.
Not necessary in a half-wave tower.
Yeah, totally different design.
If I would copper plate all the property we owned, I couldn't improve the efficiency by more than 2%.
Gee. What about the cooling system up there? I see those old ponds are still there in front of WLW.
Yes, those are raw water cooling. We cooled the tubes with distilled water, and then we'd run that through a Westinghouse heat exchanger, boiler type heat exchanger, pump the raw water through the heat exchanger out to the ponds to cool it. We had a lot of heat to dissipate. Well, here's the thing. To get 500 kilowatts output, you need 3 times that input. So twice that is going away in heat somewhere.
Yeah.
So you got a megawatt of heat you got to get rid of.
Gee, it's a shame you couldn't use that heat for something. I guess you could heat the building with it.
Oh, we did heat. We heated this building. When we shut the transmitters down, there's no heat in this building.
Yeah. Yeah, that's what we talked about that with Dave Snyder when we were here last year, and some of the damage that came from not having any heat in here. Was VOA, did you have to have cooling pods here, or the technology at a point that wasn't necessary?
No, we had radiators.
Radiators.
Then they went to the steam tubes, the tubes that actually boiled into steam, condenses back to water.
Yeah, I remember seeing that. That was really interesting.
I didn't do much on the inside of the building. All my work was outside.
Yeah.
And crossbar switch, impedance transformers, transmission lines, and antennas.
Was there much maintenance on that?
We had 2 men full-time just to maintain the antennas.
Full-time. So would they have a regular schedule of things maintenance they had to do to make sure that everything was going to be?
There was always something broke.
Yeah.
An insulator cracked, transmission line would break. They were busy.
I imagine so. But they did a great job on this facility. Same with WLW. Both of these are iconic places. Nothing else like them in the world.
They're a lot of fun to work.
I guarantee you they're bound to have been. Clyde, we really appreciate you talking with us. This has been great to hear some of these stories from you and learn a little bit about the history of broadcasting from somebody who was actually here through a lot of it.
Well, I got this all documented on a video, DVD. I'll give you a copy.
We'd love to see it.
Thank you.
Thank you, Clyde.
Should we say amen?
What was the thing you have to say for the nuns to leave?
Go in peace, the ass is mended.
Yeah, there you go.
Remember that?
He told me a good story about that a minute ago.